Okay, so on this one, the rate of change of the number of international telephone calls billed in the US between 1980 and 2000 can be described by, and they give us this function p of x, and where x is the number of years since 1980. So we're supposed to evaluate from 5 to 15 p of x dx. So we're supposed to basically take the integral of this, all right? So what we're going to do is we're say a, and we're going to have from 5 to 15 of 32.432 e to the 0.1826x, and then dx. Okay, so we can do this several ways. We can actually go and write out what the integral is, and then go rate it from 5 to 15, or 5 to 15, or we can just plug this directly into our calculator. So both ways are going to work. We're going to get the same answer. So if we did this, that would be 32.432 e to the 0.1, not 0. 0.1826x all over 0.1826. And again, because this is a specific one, then it's going to go from 5 to 15. And both of these we can plug into our calculator, but this one you have to plug all in with 15 minus all this plugged in with 5. Whereas if we do it the other way, we can just say math 9 from 5 to 15 of, and now we plug in our 32.432 e to the 0.1826x, and then we go down and we have another x, and then we hit enter, and we get 2305.357. Okay, so and that, if you did it this way too, you should get the same value. It's 2305.357, and it's going to be, it starts out as a million calls per year, so the per year goes away, and we have million calls. Okay. Now, interpret the answer from part A. All right, well, so part B says, well, between 1985 and 1995, it looks like. So between 1985 and 1995, the number of calls billed, international calls billed in the US increased 2305.357 million calls. I guess I should put by. And again, the number of these are the international. Okay, and so that's kind of an interpretation. So between 1985 and 95, the number of calls increased by that many. And so, if I'm not sure what the equation would look like, but it would have some kind of a thing where we'd have a curve, and we're looking between 2 years, and so we're looking how much it increased. So that's going to be kind of like the area between those points. Okay, and I'm not saying that this is what the curve looks like. I'm just saying that it's going to be something like that. We're looking at the area. All right, snowpack. This one we have a piecewise function. So it says the rate of change of the snowpack in an area in the Northwest Territories in Canada can be modeled by. And so we have this part of the equation when t is between 0 and 70, and the quadratic when it's between 72 and 76. And s is measured in centimeters per day, and t is the number of days since April 1st. So we're supposed to evaluate this and interpret the answer. And then we're supposed to evaluate between 72 and 76 and interpret the answer and explain then why it's not possible to calculate 0 to 76 of s of t. So what we're doing is for part A, we're on 0 to 70, and we're just looking at the first piece of 0.00241 t plus 0.0290, and that's a dt. And again, we could go ahead and take and do the integral, and so that would be 0.00241 t squared over 2 plus 0.0290 t, and then we're going to go from 0 to 70, and both of these will give us the same thing. And again, I'm just going to plug it in this way, because this way you have to plug in 70 here and here minus the 0 and 0 there. And so it's going to give us that key thing. And if you notice, if we plug in 0, that's gone, that's gone. So it's really only the 71. So really it's going to be just the 70. But we'll do it with the integral way. Math 9, 0 to 70 of 0.00241 x, and then plus 0.0290, and then that's dx. And it looks like it's 7.9345. So if we go to 3 decimals, 935. All right, so that's 7.935, and it's in centimeters, okay? And so that's between 0 and 70. Now we're going to do B, integral from 72 to 76 of 1.011 t squared minus 147.971 t plus 5406.578 dt. And so that's going to be equal to, now if we again expand it out, 1.011 t to the third over 3 minus 147.971 t squared over 2 plus 5406.578 t, evaluated from 72 to 76. Again, both of those are going to give us the same answer. And so we'll just type it in as the integral. It's going to be easier. We don't have to do two things. So math 9, and we're going from 72 to 76. And it was the 1.011 x squared. And then we had minus 147.971 x, and then it was plus 5406.578, and then out here we had an x, and so that gives us a negative 22.768. Okay, so negative 22.768 centimeters. And so that is what it did after that. So what we need to do is now, do we have hopefully another page? Yes, we do. So for part A, the interpretation was in the 70 days since, I think it was April 1st, the snowpack increased. It was 7.935 centimeters. And for part B, that was between 72 and 76 days past April 1st, the snowpack decreased 22.768 centimeters, okay? Now, explain why it's not possible to calculate the value of 0 to 76. Well, if we look at our piecewise function, it goes from 0 to 70 and then 72 to 76. So we're missing pieces here in the middle from 71, and basically we're missing 71 if we're going by whole days. And so, oops, not that. I don't know what I'm doing. I want just the next page. There we go. And so for C, it's not defined between 70 and 72 days. So we don't know what to do there, okay? So that's the key thing there. We don't know what to do, and so it's just, we can't do the integral from 0 to 76 in that manner. All right, so here we have a museum temperature. So the rate of change of the temperature in a museum during a junior high school field trip can be modeled as, and they give us that thing where the output is measured in degrees Fahrenheit per hour, and H is the number of hours after 8:30 a.m. So we're supposed to A, calculate the area of the region that lies above the axis between the graph of T and the H axis between 8:30 and 10:15, and interpret the answer, and then calculate the area of the region that lies below the axis between the graph of T equals of t and the h-axis between 8:30 and 10:15, interpret that answer. And then there are items in the museum that should not be exposed to temperatures greater than 73 degrees Fahrenheit. If the temperature at 8:30 was 71 degrees Fahrenheit, did the temperature exceed 73 degrees Fahrenheit between those times? All right, so what all do we need to do? Well, we need to probably graph this and see what it looks like. So let's go do that first. And we'll use our calculator, clear that out. And so it was 9.07 x to the third, and then minus 24.69 x squared plus 14.87 x minus 0.03. Okay, and so what does that look like? All right, that's our graph. So we need to know kind of where those pieces are, the different intercepts. So let's go and do number 2, and so that's negative, so that's good. We'll choose that. Right of that is positive. And so our first one's 0.002. So that one we would not worry about because we're going from 8:30 in the morning and all the way up to 10:15. So that one's fine. So we don't really need that. How about the next one? Let's go up here. All right, so we'll do that, and we'll do that. And so 0.89550 is that one. So that's one point we're gonna have to think about because that's gonna give us a positive area. And well, let's see where that last one is. So let's do another 0. And so we go over here. Oops. That one and that one. And we'll guess that. And so that's 1.82460. All right, so now we've got our zeros. Oops. So now let's say, look like our graph. Let's maybe draw it up here. And it was basically up and down and up again. And so this was roughly the 0. Here, this was, and we had, I think it was 0.89550, and this one was 1.8246. Okay, so that helps us. And so now what we have to think about is, okay, well, 8:30 and 10:15. So 8:30 to 9:30 is an hour, and then to 10 is an hour and a half, then 10:15 is 1 3/4 hours. So that's basically 1.75 after this times 0. So that's 0, that's 1.75. All right, so I think now we have everything to do. Now we just have to start calculating the regions. All right, so first one. For A, we're going to go from our integral from 0 to the 0.8955 of 9.07 h to the third minus 24.69 h squared plus 14.87 h minus 0.03. Now my question is, did I actually put that 0.3 in there or not? Because I don't remember doing that. Oh, I did. Okay. All right. So now what we have to do is do our calculation, math, 9. So we're going from 0 to 0.8955, and we did it in y1. And that is x. All right, so that looks good. So that should give us our value. We get 1.483, and that doesn't round up, so we'll use that for that value. And so that's dH equals 1.483 degrees Fahrenheit. Okay, interpret the answer. Well, between 8:30 and so 0.8995. Let's do that quickly on our calculator. 0.8955 times 60. So that's 53.73. So that's going to be 9, and that's going to be 54 minus 30. So 9:24. 9:24 a.m. The temperature increased by 1.483 degrees Fahrenheit. So that's our interpretation, because it went up, and so that area of this is 1.483 degrees Fahrenheit. Now B, we're going to go from 0.8955 to, and now we don't have to go all the way to here. We're going to go to some place that goes here. So we're only going to go up to, 1.75. So that's going to be our limit there. And again, we're going to go from 9.07 h cubed minus 24.69 h squared plus 14.87 h minus 0.03 dh equals, and we'll use our trusty calculator one more time. And so, oops, I'm going to just come over here. Let's delete all of that. So that's going to be 1.75. Down here was 0.8955. And we get a negative 1.607. Okay, so that's a negative 1.607 degrees Fahrenheit, or dropped 1.607 degrees Fahrenheit. Okay, so between the 9:24 a.m. and our 10:15 a.m., the temperature dropped 1.607 degrees Fahrenheit. Okay. All right, so that interprets A and B. So we've got those two. Now, there are items in a museum that should not be exposed to temperatures greater than 73. So did it exceed that? Well, if we take where our starting was, so we can put C here, we started at 71 degrees Fahrenheit, and then we went up 1.483 degrees Fahrenheit. So 71 plus 1.483 is going to give us 72.5 degrees Fahrenheit roughly, if I round it to one decimal place. So that means it was not affected. And so not affected as was below 73 degrees Fahrenheit. Okay, so that's good. So, we got our one answer, we got our second answer, and then our last answer showed that it was below that 73. Okay. All right, so let's stop there for a second. We'll come back for more.